Descartes Rule of Signs, section 3.6. The list of possible rational roots referred to in the rational roots theorem can be quite long. Descartes' Rule of Signs has two parts that can help shorten the list of possible rational roots. Part A, the number of positive real roots or zeros of a polynomial f of x with real coefficients is either equal to the number of sign changes as you go from the highest power to the lowest power of x, or it's less than that number by an even integer. And likewise, the number of negative real roots or zeros of polynomial with real coefficients is either equal to the number of sign changes in f of minus x as you go from the highest power to the lowest power, or less than that by an even integer. And we're skipping zero coefficients. Okay, so example, 2x to the 17th plus 5. And again, we're skipping powers of x where the coefficient is 0. We just have two numbers here, 2 and 5. They're both the same sign, so there's no sign changes. So there's no positive real root. Part B, f of minus x is 2 times minus x to the 17th plus 5. Negative sign to the 17th power is going to be negative. So here we have one sign change. We're going from negative 2 to 5. So that's one sign change. So that means that f of x has exactly one negative real root. Next example, f of x is 2x to the 17 minus 3x to the 16 plus 4x to the 11th minus 5. F of x has three sign changes. So we're going from 2 to negative 3, that's 1. Negative 3 to 4, positive 4, that's 1. And positive 4 to negative 5, that's another sign change. So there's altogether there's three sign changes. So that means the number of positive real roots has to be either 3 or 2 less than that, which would be 1. So either 1 or 3 positive real roots. Part B, f of minus x. So if you replace x by minus x, we have negative x to the 17th power. A minus sign to the 17th power is going to be negative. So that'll be negative 2x to the 17. Replace, and we have negative x to the 16. A negative sign to the 16th power is going to be positive, but we already have a minus sign in front of the 3, so that's still going to remain negative. Negative x to the 11th, minus sign to an odd power is going to be negative, so that'll make this negative 4x to the 11th. And the last term is already, just copy that the way it is, that's negative 5. So here there are no sign changes. So there's, we go from negative 2 to negative 3 to negative 4 to negative 5. These are all negative. There's no sign change. So the original function f of x has no negative real root. Will be either 1 or 3 positive real roots and no negative real root. And that concludes this presentation.